lesson, I will discuss faults and its significance in engineering construction. But before we proceed to our main topic, let's have an overview of faults first.
What is a fault? Beyond a certain point, it rocks will break. When enough stress builds up into a rock, the rock breaks. And we call that break in a rock a fault. A fault is a fracture or zone of fractures between two blocks of rock. Faults allow the blocks to move related to each other, and they usually occur along the plate boundaries where forces of plate motion can either compress, they can pull, or they can shear past the crust so that it breaks. There are three types of faults that we're going to talk about today. The first of all I want to talk about is called a normal fault. This is created by force called tension. Make sure we remember that normal faults are caused by tension. Tension is what happens when you take, let's say, a rope and pull really hard on both sides of it. If the stress of that rope is under, it causes that tension. So what happens with rock is when the rock gets stretched out, it becomes thin in the middle. This happens at divergent boundaries because the plates are moving away from one another. The second type of fault is called reverse fault. In this kind of opposite of a normal fault and a reverse fault, its compression causes it squeezing the rock until it ends up folding or breaking. The third kind of fault is called a strike-slip fault. This occurs when stress that pushes a massive rock in two opposite directions. This is called shearing. So remember, strike-slip fault is formed from shearing. This occurs at transform plate boundaries, which is when two plates slide past each other. This by the fault is also one that causes earthquakes. Now, the extent of what you feel an earthquake is caused by the friction that is between those two plates. If there's not a lot of friction and they move really slowly, you're not going to have a major earthquake if they slide past one another easily. But if there's a lot of friction and they have a hard time when they finally snap, then you're going to have a major earthquake. Now, these cracks in the earth can build mountains. When a normal fault uplifts a block of rock, we call it a fault block mountain. When two normal faults form when they're parallel to one another, what ends up happening is that a block of rock is left lying between them as the hanging wall of each fault slips downward. The block in between then moves upward and it creates a mountain. The opposite of the flow, when a block of rock lying between slides downward, then we have a valley that forms. Sometimes, instead of actually faulting plate movements can just cause the crust to fall. Fold your bends in the rock. The formal compression either shorten or thicken part of the earth's crust. Think of it like a towel. If I have a towel laid out and I take the two ends and slide inwards, the towel just going to make faults. That's what happens when two plates collide together. Collision of these two plates is what causes the folding in the crust. I've ever heard of the Himalayas mountain. These are examples of folding mountains. Now, when a fold happens, sometimes it can bend into an arc going upward. This is called an anticline. But sometimes a downward beam forms and this is called a syncline. We are right now proceeding to the main topic, which is the importance of faults in engineering construction. Faults are important in engineering construction because of their various dangers as well as functional effects. Example of this is geological maps. Faults and other geological structures help us to make geological maps, which we use to infer underground structures where we can see the rocks, and to help us understand the formation of geologic resources to next is the groundwater. The faulting patterns can have enormous economic importance. Faults can control the movement of groundwater, and they can have a major influence on the shaping of the landscape. Next is the earthquake geology. Faults in earthquake geology in strengthening a building. It is important to reduce earthquakes force building and subjecting to understand the risk that different areas may face for earthquake hazards. We need to know where the faults are and how they behave a fault if it has produced an earthquake or left a mark on the surface of earth. Make sure you know the three types of fault, you know the force that causes each fault, and you know what happens as a result of those faults. Also make sure you know what is anticline and syncline mean. And remember the importance of faults in engineering construction.